Our world is just full of uncertainty, right? Surprises, chaos, things we can't predict. But what if I told you there's a tool, a fundamental way to actually measure it, to analyze it? Well, there is. And today we're going to pull back the curtain on the core concept that makes it all possible, the random variable.
Okay, so picture this. You roll a single die. Simple, right? The number that pops up? Well, that's completely random. It could be a 1, could be a 6, could be anything in between. You have no idea what you're going to get. And that, right there, is the heart of what we call a random experiment.
But here's where it gets really interesting. What if we could somehow tame that chaos, take all that unpredictability and slap a number on it, in a way that actually makes sense? What if we could measure it? And that, my friends, is exactly where the random variable steps in. This isn't just some dusty old math term. This is the bedrock of statistics, probability, and yeah, even a lot of modern AI. So let's get to the big reveal. What is this thing? All right, first thing you need to know, the name random variable is, well, it's kind of tricky. It's not really random, at least not in the chaotic way we think of it, and it's not a variable like the x you might remember from algebra class. Nope, it's something way, way smarter.
Here's the key, the absolute heart of it. A random variable is basically a rule. Think of it like a translator. Its entire job is to look at every single possible thing that can happen in an experiment, like all the sides of a die, and assign a clear, specific number to each one. It turns real-world stuff into numbers we can actually do math with.
Okay, I get it. Saying it's a rule can still sound a little floaty. So let's bring this down to earth with an example we all know and love.
So here we go. Step 1, the experiment. We roll a die. Easy enough. Step 2, what can happen? Well, the die can land on a 1, a 2, a 3, 4, 5, or 6. Those are our possible outcomes. And now for step 3, the rule, our random variable. In this case, the rule is super simple. Whatever number is facing up, that's the value we assign. So instead of just saying, hey, I rolled a 3, we can now say something way more powerful. Our random variable has a value of 3.
And you might be thinking, okay, so what? Well, this is the magic. Think about flipping a coin. The outcomes are heads or tails. You can't really do math with words, right? But what if our random variable sets a rule? Heads equals 1 and tails equals 0. Boom! Suddenly we can. We can find averages, spot patterns, analyze trends. We've just turned pure randomness into something we can quantify. That's the game changer. Now, it turns out that randomness isn't all one size fits all. Random variables basically come in 2 main flavors, and this helps us get way more specific about the kind of uncertainty we're looking at. So on one side, we have what are called discrete random variables. Think of these as things you can count, like steps on a ladder. The result of that die roll can be a 3 or it can be a 4, but it can never be 3.5. They are distinct, separate values. Then, on the other side, you have continuous variables. Think of this more like a ramp. A person's height isn't just 1.7 meters or 1.8 meters, it can be any value in between. So one is about counting, the other is about measuring. All right, so a random variable is pretty cool on its own, but it has a sidekick, a partner in crime that really unlocks its true power. And that partner is probability. This is where things get really predictive. See, it's one thing to know that a die can land on the numbers 1 through 6. That's useful. But the really juicy information, the real insight, comes when we know the chance of each of those numbers popping up. What's the probability? These two ideas, the value and its chance, are totally linked. So let's go back to our fair die. Our random variable, we'll just call it x, can take the value of 1, right? And the probability of that happening is 1 in 6. What about x being 2? Same deal, 1 in 6. And it's the same for 3, 4, 5, and 6. Look at what we just did. We haven't just listed what can happen, we've mapped out exactly how likely each outcome is. And this whole thing, this complete picture of all the possible values and all their matching probabilities, that has a special name. It's called a probability distribution. You can think of it like a complete roadmap for uncertainty. It's not just a list of destinations, it tells you the traffic on every single road. And let me tell you, this map is basically the engine under the hood of all modern statistics, data science, and AI. So maybe this all seems a bit simple. A rule, some numbers, probabilities. What's the big deal, right? Why should you care? Well, let's get to the so what of all this, because it's absolutely huge. The thing is, because random variables are our #1 tool for wrangling uncertainty, they are literally everywhere.
The financial models that try to predict the stock market, built on them. The algorithms that tell you if it's going to rain tomorrow, yep. Even the mind-bending world of quantum physics, it all starts with this one simple, powerful idea, turning randomness into numbers we can actually work with. So, if there's just one thing you remember from all this, make it this. A random variable is a bridge. It's the bridge that connects the messy, unpredictable real world to the clean, orderly world of mathematics. It lets us take chaos and finally start to make sense of it.
And that leaves us with one last big question. We started with something as simple as a die roll, but now that we have this amazing tool, this framework for turning any uncertainty into numbers, just think about it. What other big, complicated, unpredictable things in our world, from human behavior to cosmic events, could we finally start to measure, understand, and maybe, just maybe, even predict?